Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Imagine this. An AI agent is browsing the web for you, finds a service it needs, negotiates access, pays the site, gets the data or tool call, and keeps working. Not ads, not subscriptions you manually signed up for, actual machine-to-machine payments on the open web. That idea is called WebMCP, and it is either the missing toll booth for the agent internet or the start of a very weird era where your website has to learn how to invoice a robot.
And important upfront, WebMCP, as it's being discussed, is not something we're treating as an official internet standard or a confirmed product launch. It's a concept gaining attention. But it points at a real question. If AI agents become the new users of the web, how do websites get paid?
Exactly. Plus, today, OpenAI has a practical ChatGPT work guide for building a personalized meal planner, which sounds cozy until you realize it's really a blueprint for every personal operations assistant you're going to build.
And we're also talking about Anthropic's work around AI systems operating physical equipment, DeepMind on uncertainty in AI, and yes, an OpenAI item simply titled Lost Cat, which is somehow both adorable and a little bit profound.
This is Semper AI Digest, the official podcast of Semper AI. It's Friday, August 28th, 2026. I'm Tomas.
And I'm Aiva.
Aiva, I cannot stop thinking about the phrase, let AI agents pay you money.
It is an extremely effective phrase.
It's like the entire internet economy got compressed into 7 words and handed to a tiny accountant with a browser.
Right, but let's slow down before we all start installing crypto toll booths on our recipe blogs.
Fair. So here's the setup. Greg Isenberg has been talking about WebMCP, and the short version is, if MCP, the Model Context Protocol, gives AI systems a way to connect to tools and data sources, then WebMCP imagines that websites could expose those capabilities directly to agents, and crucially, those agents could pay.
So instead of a human landing on a page, seeing ads, clicking around, maybe signing up, an AI agent could say, I need access to this database, this API, this article, this booking flow, or this specialized calculator. What does it cost?
Yes, the web stops being just pages and becomes a market of callable capabilities. And this is where my brain lights up like a server rack at midnight, because the current web is built for eyeballs. Agents don't have eyeballs, they have tasks.
That's the core shift. The business model of the consumer web assumes attention. Search drives traffic, traffic monetizes through ads, subscriptions, affiliate links, or lead generation. But if an agent summarizes 10 pages without visiting them in a human way, the old value exchange breaks.
Exactly. If my agent asks, find me the best contractor for a bathroom remodel under $12,000, check availability, verify licenses, compare reviews, and draft outreach, it doesn't want to scroll through 15 SEO pages titled, Top 10 Bathroom Contractors in Your Area, number 7 will shock you.
And nobody wants that.
Nobody. The agent wants structured data, trustworthy actions, and permissioned access. So WebMCP is basically saying, let websites package up their value as tools an agent can call, and let the agent pay for those calls.
There are a few layers there. One is technical. How does the website expose functions to an agent? Another is economic. How does pricing work? Per call, per outcome, subscription, auction. And then there's trust. Who is allowed to spend money, and how does a user prevent their agent from accidentally buying 17 enterprise reports and a forklift?
Wait, hold on. 17 enterprise reports and a forklift is actually how most digital transformation projects begin.
Unfortunately plausible.
But that's the scary fun part. Payments make agents more useful, but they also introduce risk. Today, if an AI assistant tells you, I found the best flight, you still usually click and purchase. In an agentic web, it might buy the flight, it might book the hotel, it might pay a research site for verified salary data, it might send a $3 payment to a niche forum to access an answer from a domain expert.
Which could be great. It could also become a mess if every site tries to charge an agent for tiny bits of access that used to be available through browsing.
Micropayment pop-ups, but for robots.
Exactly. We've been here before conceptually. The web has wanted micropayments for decades. The challenge was always friction. Humans don't want to approve 20 tiny payments while reading the news. Agents might handle that friction better, but the human still needs budget controls and transparency.
So you need something like, my research agent can spend up to $20 per day, no more than $2 on a single source without asking, and only on vendors with verified reputation. Suddenly, the browser becomes a wallet, a procurement department, and a risk engine.
And that points to why MCP matters in this conversation.
MCP is about standardizing how models connect to tools and context. If you extend that idea to the web, websites are no longer trying to reverse engineer how to serve AI crawlers. They can intentionally expose capabilities.
Like a restaurant putting out 2 menus, one for humans, one for agents. The human menu says handmade seasonal pasta. The agent menu says here is availability, price, ingredients, allergens, reservation function, deposit policy, cancellation policy.
That's a vivid analogy and actually useful. The agent menu has to be machine readable, but it also has to preserve the business's interests.
Right, because right now, a lot of publishers and website owners feel like AI systems are eating the buffet and not paying the check.
And this is where we have to be careful. WebMCP as a concept does not solve all of that automatically. It doesn't answer by itself how copyright works, how consent works, whether sites can negotiate fairly with large AI platforms, or how small creators avoid being squeezed.
Totally. My optimistic take is that it gives us a better shape for the conversation. Instead of block all bots versus scrape everything, maybe there's a middle path where sites say, here are the services we provide to agents, here's what you can do, here's what it costs, here's what you may not do.
That would be healthier than the current ambiguity. But I'd add one grounded point. Standards only work when enough players adopt them. If WebMCP remains a catchy idea, it's a thought experiment. If browsers, AI labs, payment providers, identity systems, and websites converge around something like it, then it becomes infrastructure.
And infrastructure is where things get boring in the best possible way.
The best infrastructure disappears.
Yes, like DNS, like credit card networks, like OAuth. Nobody wakes up excited about OAuth except maybe 3 people, and I respect them deeply, but the whole internet runs on these invisible agreements.
So if we imagine agent payments becoming real, what would need to exist?
Okay, first, identity. The website needs to know, is this agent acting for Aiva, Semper AI, a botnet, or an anonymous scraper wearing a trench coat?
Strong visual.
Second, authorization. The agent needs scoped permission. It can pay for an article. It cannot drain your bank account. It can book a restaurant up to a budget. It cannot buy a timeshare in Myrtle Beach because an affiliate page said it was life-changing.
Third, receipts and audit trails. You need to see what the agent bought, why it bought it, and what it got in return.
Fourth, dispute resolution. If the agent pays for bad data, who handles the refund? The user? The agent platform? The website? The payment provider?
And fifth, security. Any protocol that lets software spend money will attract attackers immediately.
Immediately, like raccoons to an unsecured campsite.
That's our second animal analogy already, and we haven't even reached lost cat.
Oh, that cat is getting a hero's welcome later.
But to close this first story, the reason WebMCP is worth discussing is not because it's confirmed as the standard. It's worth discussing because it captures the collision between AI agents and the web's economic model.
And my big takeaway is, the agent web needs a cash register. Maybe WebMCP is that, maybe it inspires something else. But if agents are going to do real work, they need real access. And real access often costs real money.
And the user needs real control.
Exactly. Control, trust, and a receipt. Put that on a sticker.
Speaking of practical systems instead of just grand internet architecture, OpenAI has a much more down-to-earth guide, how to build a personalized meal planner with ChatGPT work.
And I love this one because on the surface it sounds like, cool, dinner help. But underneath, this is one of those deceptively simple workflows that shows why workplace AI adoption is not always about giant moonshot projects.
Right. A personalized meal planner is approachable. Everyone understands the problem. You have preferences, constraints, a schedule, maybe dietary needs, maybe a budget, maybe ingredients already in the fridge. The task is repetitive, but it also needs judgment.
It is the perfect little sandbox for AI because the model has to gather requirements, reason across constraints, produce a plan, and revise when the human says, actually, Tuesday is chaos and I hate lentils.
Which is valid.
Strongly valid. And in a work context, the interesting thing is not the meal plan itself, it's the pattern. Replace meal planner with weekly content calendar, sales outreach planner, employee onboarding checklist, travel itinerary, or project sprint plan.
That's the broader point. A good personalized AI workflow usually has 4 pieces: context, constraints, generation, and iteration.
Say that again. That's the whole thing.
Context: what does the assistant need to know? Constraints: what rules does it have to follow? Generation: what output should it create? Iteration: how does the human review and refine it?
With meal planning, context might be household size, favorite cuisines, cooking skill, pantry staples. Constraints might be calorie targets, allergies, budget, time per meal. Generation is the plan plus recipes plus shopping list. Iteration is swap fish for chicken or make Thursday leftovers friendly.
And because OpenAI is presenting this as a ChatGPT work guide, the implicit lesson is that business users can build reusable workflows without necessarily becoming software developers.
This is where I get animated. For years, enterprise software has made people adapt themselves to rigid tools. AI flips that. You can describe the workflow in natural language, then gradually formalize it.
Although gradually formalizes doing a lot of work there.
It is, and you're right to jump in. A casual prompt is not the same as a reliable business process. If you're using ChatGPT for a meal plan, the cost of a mistake might be buying too many avocados. Annoying, but survivable.
Unless they're very expensive avocados.
True. In this economy, that's basically a procurement failure.
But in a business setting, if the equivalent workflow is compliance documentation or customer pricing, you need validation, permissions, and review. So the meal planner is a friendly example, not a reason to automate everything blindly.
The magic is in learning the muscle. People get hands-on with structured prompting. Ask me clarifying questions first. Use this format. Create a shopping list grouped by store section. Optimize for leftovers. Those are the same skills that make AI useful at work.
It also shows why personalization is more than a buzzword. A generic meal plan is easy. A useful meal plan has to account for the actual person. In organizations, generic AI output often disappoints because it lacks company context.
Yes. The difference between write a sales email and write a sales email using our positioning for this industry based on this account history with these compliance rules is enormous.
And that connects back to WebMCP, oddly enough. Agents become valuable when they can access the right context and services. A meal planner gets better if it knows your calendar, pantry, grocery prices, dietary preferences, and cooking equipment.
Callback achieved. The agent needs both memory and permission. It needs to know you have a blender. It does not need to know your entire medical history unless you explicitly choose that, and there's a good reason.
Exactly. Personalization raises privacy questions. Food preferences can be sensitive. Health goals can be sensitive. Family schedules are sensitive. So even with a friendly example, users should understand what they're sharing and why.
My take? This kind of guide is how AI becomes mundane, and mundane is powerful. We spend so much time talking about frontier models breaking benchmarks, but the real productivity gains often come from small workflows repeated thousands of times.
The humble checklist, the weekly plan, the reusable assistant.
The please make my life 10% less chaotic bot.
Honestly, that one would have a huge market.
Massive. And if it can also prevent me from buying cilantro when I already have cilantro, we are entering a golden age.
Let's not overpromise cilantro intelligence.
Fair. Now, our third headline from OpenAI has the shortest title and maybe the widest interpretive radius: retirement.
This is one where we need to be precise about what we know. The item we have from OpenAI is titled retirement. We do not have a long set of details in the source brief for today, so we should not invent specifics.
Right. We're not going to claim a particular model, feature, or policy is being retired unless it's in the confirmed material. But the reason this is worth a headline discussion is that retirement has become one of the most important and underappreciated parts of the AI product lifecycle.
Especially for AI systems that businesses build on top of. A retirement notice can affect applications, workflows, costs, compliance documents, training materials, and user trust.
Totally. Model launches get the fireworks. Model retirements get the calendar invites with ominous subject lines.
Less action required.
The two scariest words in enterprise software.
But retirement is necessary. AI providers can't support every model, endpoint, feature, or behavior forever. Older systems may be less capable, less efficient, harder to secure, or inconsistent with current feature practices.
And for developers, the question is, how much warning do I get? How easy is migration? And will my application behave differently after I switch?
That last part matters a lot. With traditional software APIs, if an endpoint changes, you can often test inputs and outputs pretty deterministically. With language models, behavior changes can be subtler. Tone changes, reasoning style changes, refusal boundaries change, tool use patterns change.
It's like replacing a coworker who technically has the same job description but writes emails differently, asks different questions, and suddenly alphabetizes the snack cabinet.
Why is that so specific?
No comment.
The serious version is that AI migration needs evaluation. If a company has built a customer support assistant, it should test the replacement model against real scenarios before the retirement deadline.
And not just does it answer, but does it answer accurately, safely, in brand voice, within latency and cost targets.
Plus, regulatory and data handling requirements. If the retired system had certain documentation or approvals, the replacement might need review.
I think the industry is still learning how to do graceful retirement. You need clear timelines, compatibility guidance, eval tools, fallback plans, and ideally a preview window where customers can compare outputs.
And communication that reaches the right people. Sometimes the person who receives the vendor email is not the person maintaining the integration.
Oh, absolutely. Somewhere, a critical API deprecation notice is sitting unread in an inbox called admin@company.com.
A small tragedy in 3 words: shared admin inbox.
So for listeners building with AI, even without extra details on this particular OpenAI item, use retirement as a prompt to check your own dependency map. What models are you using? Which features? Where? Who owns them? What's your migration plan if they change?
That's practical. Keep an inventory. Track model versions. Write evaluations. Don't rely on vague vibes like, the new model seems better.
Vibe-based migration is what happens right before the incident review.
Exactly. And from the provider side, retirement is also a trust moment. If users feel surprised or stranded, they lose confidence. If retirement is handled clearly, it can actually reinforce trust.
Because it says, this platform is evolving, but we're not yanking the floorboards while you're walking.
Good metaphor.
Thank you. I've been workshopping floorboards since the cilantro bit.
It shows.
All right, let's shift from retirement to something with more whiskers. OpenAI also has an item titled Lost Cat.
This title is doing a lot of emotional work.
It really is. And again, we only have the title level detail here, so we're not going to embellish a specific story. But Lost Cat as an OpenAI item immediately brings up one of the most human uses of AI, helping in small, urgent, messy real-world situations.
A lost pet is a perfect example of a problem where people are stressed, time matters, and the task involves coordination. You might need flyers, search radius planning, social posts, shelter contact lists, door-knocking scripts, and a timeline.
It's not glamorous AI. It's not solve quantum gravity. It's my cat is missing and I need a plan in 10 minutes.
And that can be genuinely valuable. An AI assistant can help organize the chaos. What to do in the first hour, what to do overnight, who to call, how to describe the pet clearly, how to make a flyer readable.
Also emotional tone. If you've ever had a pet go missing, your brain becomes a browser with 200 tabs open and all of them are playing alarm sounds.
That is accurate.
An assistant can say, start here, put food and familiar bedding outside, check hiding spots nearby, contact local shelters, post in neighborhood groups, make a flyer with a clear photo. Not because it has secret cat magic, but because it can turn panic into sequence.
The caveat is important. AI advice should not replace local expertise, animal rescue organizations, or common sense. And if the model gives advice, users still need to verify what's appropriate for their location and situation.
But this is the class of AI use case that wins hearts. It's not abstract, it's immediate help.
It also shows how multimodal AI could matter. If someone has photos, maps, sightings, or security camera images, an assistant could help organize information. But any image-based identification should be treated carefully because false positives can waste time.
Right. This blurry raccoon is definitely Mr. Pickles is not helpful.
Poor raccoon.
Poor Mr. Pickles. But seriously, I like these stories because they remind us that AI usefulness isn't always measured in enterprise ROI. Sometimes it's measured in whether someone feels less alone while solving a hard problem.
And whether the tool helps them act.
Exactly. AI as a calm checklist generator might be one of its underrated superpowers.
From cats to lab equipment is quite a turn, but there's a thread. AI moving from text into the physical world.
Yes, Anthropic has a story on the model hardware standard, AI operating physical equipment, and this is one of those areas where the stakes jump dramatically. When an AI writes a bad paragraph, you edit it. When an AI operates hardware, something can move, heat, spin, cut, mix, or break.
That changes everything. A model interacting with physical equipment needs much more than a prompt and a tool call. It needs constraints, safety boundaries, permissions, state awareness, and emergency stops.
The phrase model hardware standard suggests a framework for how AI systems should interface with machines. Think of it like giving models a standardized, safety-conscious way to understand what a device is, what it can do, what it should not do, and what confirmation is required.
And that standardization matters because physical equipment is diverse. A lab robot, a microscope, a 3D printer, a robotic arm, and an industrial pump all have different capabilities and failure modes.
If every integration is bespoke, you get a jungle of adapters. Some are safe, some are duct tape with a Python script and a prayer.
That is not an acceptable safety architecture.
No. Very official stands from Semper AI Digest. Do not run your centrifuge on vibes.
The broader trend is that AI systems are increasingly being connected to tools that affect the real world, so the interface needs to describe not just actions, but consequences.
For example, move arm to coordinate X is not enough. The system needs to know what's in the path, whether a human is nearby, whether the payload is fragile, whether the motion exceeds safe limits.
And it needs layers of control. Some actions can be autonomous, some require human approval, some should be blocked entirely unless the system is in a simulated or locked-down environment.
That's huge. Simulation before execution. Dry runs, permission gates, logs, rollbacks were possible. Although in the physical world, rollback is sometimes buy a new beaker.
Or clean the floor.
or evacuate the building in worst cases. So yes, safety.
What I appreciate about standards work in this area is that it can make safety scalable. Instead of every team inventing its own way for a model to talk to equipment, you define common patterns.
And once you have common patterns, you can audit them, test them, certify them, maybe even insure them.
Insurance is a surprisingly good lens. If an AI system operates hardware, organizations will need to prove they had reasonable controls.
The future of AI agents is not just cool demos, it is risk paperwork.
Always has been.
Always has been. And Anthropic also has a related story. AI models can now help run physical science experiments.
This is where the hardware standard becomes more concrete. Scientific experiments often involve instruments, protocols, measurements, and iteration. AI can help plan experiments, operate equipment under constraints, monitor results, and suggest next steps.
I love this because science is basically the original agent loop. Hypothesis, action, observation, update. Hypothesis, action, observation, update.
That's true. A lab assistant model could help choose parameters, schedule runs, analyze early results, and flag anomalies.
Imagine a material science lab where the AI says, based on the last 20 trials, adjust temperature slightly, change the ratio here, run 3 replicates, and compare against the baseline. Then it coordinates instruments to do that, with human oversight.
The oversight part cannot be optional. Physical science has safety, contamination, reproducibility, and cost concerns. A model may suggest a promising experiment, but it should not have unrestricted control over a lab.
And reproducibility is key. If AI helps run experiments, every step needs to be logged. What did it propose? What command was sent? What instrument state existed? What data came back?
Otherwise, you get results that are hard to trust. Science needs traceability.
There's also a democratization angle. Smaller labs could use AI to help manage complex instrumentation or explore parameter spaces more efficiently.
Potentially, yes, but access to physical equipment still matters. AI can help design or coordinate experiments, but it doesn't eliminate the need for instruments, materials, technicians, and domain expertise.
So not press button, discover cure.
No.
More like make the loop faster and more organized.
Exactly. And maybe help researchers notice patterns or options they might not have prioritized.
This is the kind of AI progress that feels less like replacing scientists and more like giving them a tireless lab coordinator who never forgets the protocol.
Provided the coordinator is well supervised and its suggestions are validated.
Yes, lab coat plus leash.
That phrasing is going to get quoted out of context.
I stand by it cautiously.
From physical uncertainty to mathematical uncertainty, Google DeepMind has an item on the mathematics of AI uncertainty.
This is one of my favorite topics because uncertainty is the difference between an AI that sounds smart and an AI you can safely use.
Models are often fluent even when they're wrong, so we need methods for estimating when a model knows, when it doesn't know, and how confident it should be.
And humans are terrible at this too, by the way. We say things with confidence because confidence is socially rewarded.
True, but with AI systems, confidence can be especially misleading because language models generate plausible text by design. A well-written answer is not the same as a calibrated answer.
Calibration is the magic word. If a system says it is 80% confident across many predictions, then roughly 80% of those predictions should be correct. That's calibrated.
In real applications, uncertainty can guide decisions. A medical AI might flag low confidence and defer to a clinician. A legal assistant might show uncertainty around a citation. A robotic system might slow down when perception is uncertain.
Or our earlier lost cat assistant might say, "This image match is weak. Don't treat it as reliable."
Nice callback.
Thank you. The math can get deep. Bayesian methods, ensembles, conformal prediction, distribution shift, out-of-distribution detection.
The accessible version is, how do we build systems that not only answer, but also know the limits of their answer?
And then communicate those limits in a way humans understand. Because a probability score buried in a log file doesn't help a nurse, a mechanic, or a lab technician.
There's also a behavioral challenge. If the model says, "I'm uncertain" too often, users may ignore it or find it useless. If it says it too rarely, users overtrust it.
So uncertainty is a user experience problem too.
Very much. The interface has to decide when to interrupt, when to ask for clarification, when to show confidence, and when to require verification.
I think uncertainty is going to become a competitive feature. Not just our model is smarter, but our model is better at telling you when it might be wrong.
That would be a healthy direction, especially in high-stakes domains.
It's like a GPS that says, "I'm not fully sure this road exists." That's annoying, but much better than confidently driving you into a lake.
Most users would prefer not to enter the lake.
Strong consensus.
And uncertainty connects back to agents spending money and operating hardware. If an agent is uncertain, maybe it should not spend. If it's uncertain, maybe it should not move the robotic arm.
If it's uncertain, maybe it asks the human.
The agentic future needs humility baked into the control loop.
Well put.
Now, shifting from model theory to go-to-market reality, Snowflake has a customer story about how POSIT grew pipeline by 173% with Snowflake.
This is a business AI and data infrastructure story. Snowflake says POSIT grew pipeline 173% with Snowflake. We should treat that as a reported customer outcome from Snowflake's materials.
POSIT, known for tools around data science and analytics, is a company that understands technical audiences. So pipeline growth in that context is interesting because it suggests data-driven sales and marketing operations can have a big impact when the underlying data stack is cleaned up.
The number is the headline, but the underlying lesson is probably about unifying data. Revenue teams often have fragmented systems: product usage, CRM records, marketing engagement, support signals, website activity.
And if those are all in separate caves guarded by separate dragons, your sales team is guessing.
That metaphor is dramatic, but yes, a modern data platform can help teams identify qualified accounts, prioritize outreach, personalize messaging, and measure what works.
This is where AI becomes useful only if the data foundation is real. People want the AI salesperson that magically knows who to call. But first you need clean account data, consent-aware workflows, clear definitions, and reliable pipelines.
Otherwise, the model just automates confusion.
Congratulations, we have scaled our bad spreadsheet.
Exactly. Snowflake's angle here is that the data cloud supports that growth engine. And for listeners, the takeaway is not simply buy tool, get pipeline. It's that data infrastructure can directly shape revenue operations.
Also, pipeline growth is not the same as closed revenue. Important nuance.
Yes, pipeline is potential future business. A 173% increase is notable, but companies should still look at conversion rates, deal quality, sales cycle length, and retention.
Aiva with the grown-up metrics.
Someone has to do it.
I appreciate it, because this is the pattern we keep seeing. AI value shows up when it attaches to a real workflow and a real metric. Meal planning has grocery lists. Lab AI has experimental throughput. Sales data has pipeline and conversion. The abstraction has to land somewhere.
That's a nice synthesis. AI is not valuable because it is AI. It's valuable when it improves a process people care about.
Put that on the other sticker. We now have 2 stickers.
We're building quite a merchandise line.
Speaking of building, it's time for our quick hit. Databricks announced Lakeflow Designer, visual pipelines, real code.
This is a strong phrase because it addresses a common tension in data engineering. Visual tools are approachable, but engineers often worry they'll generate opaque workflows that are hard to version, test, or maintain.
Visual pipelines, real code says drag and drop convenience without trapping your logic inside a mystery box.
If implemented well, that can help mix teams. Analysts and data engineers can collaborate visually while still keeping code as the durable artifact.
It's like sketching the plumbing diagram and still getting actual pipes, not a watercolor of pipes.
Another infrastructure metaphor. Very on brand today.
Thank you. The bigger Databricks story is that data pipelines are becoming more accessible, but production standards still matter: observability, lineage, testing, scheduling, and governance.
And that loops back to everything else. Agents, meal planners, lab systems, sales workflows, they all depend on data moving reliably.
The glamorous AI future rests on deeply unglamorous pipelines.
Always.
So let's bring this home. Today's episode had this fascinating arc. We started with WebMCP and the idea that AI agents may need to pay websites directly. Then OpenAI's Meal Planner showed how everyday workflows become personalized AI systems. Retirement reminded us that AI products have life cycles. Lost Cat brought the human side. Anthropic moved agents into physical equipment and science labs. DeepMind gave us the math of uncertainty.